All right. So a couple weeks ago before the break, I was talking about how we got to anything to the 0 power equals 1. And I think I showed a pattern on the whiteboard over there. I'm going to go ahead and write this in on our notes today, but go ahead and get things titled first of all. We got negative exponents, that's the topic. And we have the 30th of March today. So negative exponents is our topic. Today's March 30th. And does anybody else need the notes still? Good. All right. So we talked about, like I said, a couple weeks ago, the exponent of 0 equaling 1. And the way that I kind of presented that was went ahead and just used a pattern here. And I said, all right, if we have like 2 to the 4th power, that's equal to 2 times 2 times 2 times 2. And that was equal to 16. So then we just said 2 to the 3rd power, which is equal to 2 times 2 times 2, which equals 8, which is equal to the previous answer divided by the base value of 2. That equals 16 divided by 2. And 2 to the 2nd power is equal to 2 times 2, which is 4, which is equal to the previous answer of 8 divided by 2. And then we can keep going with this and say 2 to the 1st power is just equal to 2, which is equal to the previous answer of 4 divided by 2. You guys remember seeing this on the whiteboard a couple weeks ago? And then we're like, okay, every single time, we're just dividing the base value by itself to reduce one of the exponents. And then we got to 2 to the 0 power, which was equal to the previous answer, 2 divided by 2, which equals 1. And so we said, all right, anything to the 0 power is equal to 1, because really what you're doing there is you're just dividing a number by itself. And so that's what the 0 power is. Today, though, we're actually going to be talking about negative exponents. And so if you think about a negative exponent, kind of like if you think about 0 power, a lot of your first instinct was to say something to the 0 power equals 0, which it wasn't. It was equal to 1. Likewise, a lot of people's first instincts with negative exponents is to say that it's going to be equal to a negative number, but it isn't. So if we keep going with this pattern, and we say 2 to the negative 1 power, that's going to be equal to the previous answer of 1 divided by the base number of 2. So that actually equals 1/2. So 2 to the negative 1 is equal to 1/2. It's not a negative number. It actually just creates a fraction. And that's usually what happens with these negative exponents is they don't always create fractions, but they don't create negative numbers. That's kind of the big thing here, is that negative exponents do not create negative numbers. And in order for something to be considered to be simplified, we can't write a negative exponent in our answer. Exponents always need to be positive. So for example, if we had 2 to the negative 2 power.
Have your attention, please. Will all juniors with the last name R through Z, last name starting with letters R through Z, please go to the Career Center for testing right away. Once again, any juniors last name starting with letters R through Z to the Career Center. Thank you.
So if we've got 2 to the negative 2 power, we'll just keep going with this for one more. Actually, we'll go to 2 to the negative 3rd. This is going to be equal to the previous answer, 1/2, divided by 2 again, which is actually.
The last name starting with letters R through Z, please report to the Career Center for testing. Thank you.
Which is actually just the same as 1/2 squared. And 1/2 squared would be equal to 1/2 times 2, which would be equal to 1/4. And so if you look at what 2 to 2 squared was, 2 to the 2nd power equals 4. 2 to the negative 2 equals 1/4. So if we said 2 to the negative 3 power, what do you think we're going to get for our answer on that one? Any thoughts there? So 2 to the negative 2 is 1/4. 2 to the 2nd power was 4. So those would be reciprocals of one another. All right. You got notes right here. Any thoughts on what 2 to the negative 3 would be? What is 2 to the third power equal? 8, right? So 2 to the negative 3 would be the reciprocal of that, which is going to be 1/8. So it's actually equal to 1 over 2 to the third power, which equals 1/8. So 2 to the negative 3, 2 to the positive 3 are going to be reciprocal values of one another, 8 and 1/8. Last one here, and then we'll start working on the notes. 2 to the negative 4, what do we think? (1/16), exactly. 2 to the fourth power was 16. 2 to the negative fourth power is just 1 over that. So that would be 1 over 2 to the fourth power. And 2 to the fourth power is 16, so it's 1/16. All right, so the idea here is when we write our answers, or when we write something in simplified form, we have to have positive exponents in order for that to work. So the negative exponent rule is up here at the top. First thing we're going to write down for our notes. Negative exponents can be written using positive exponents, using the negative exponent rule. So if you have any number or variable with a negative exponent, the way to write this with a positive exponent would be to put this entire thing underneath 1, and then that makes your exponent positive. So this would be 1 over x to the a power. So it goes from a negative exponent to a positive exponent when you move, basically when you move something from the numerator to the denominator. But it also works the other way, and I'll show you what that looks like in a little bit. So something we need to keep in mind is well, for this first one, let's just go ahead and write this one. X to the negative 5th power, that's going to be equal to 1 over x to the 5th power. So you just put the variable in the exponent on a denominator, put a 1 over it because there's nothing else on the numerator except for 1. And the x itself doesn't change in any way whatsoever. The variable stays exactly the same. The only thing that changes is your exponent goes from a negative to a positive, moving it from the numerator to the denominator. Now on the second one, something that people get in trouble with on problem number 2 is they will write, and I'll just write this on the whiteboard. They'll write the answer as 1 over 3m squared. 1 over 3m squared, which actually is not the answer. So don't write that down. This is one of the things that gets people in trouble is because they'll look at this whole thing and they'll say, okay, the exponent is -2, so everything has to go to the denominator. However, the only thing here with the exponent is m. The 3 does not have its own exponent. The 3 is just a 3. So what ends up happening here is the 3 actually stays where it is. The 3 stays on the numerator, and just the variable in the exponent move to the denominator. So we get 3 over m squared. We're not going to have a 1 on the numerator this time because we didn't move everything to the denominator. We still have something up here that was originally there. So only the variable with the negative or the number with the negative exponent moves from the numerator to the denominator. So on number 3, the only thing that we're going to move on number 3 is the a to the -4. By the way, this -7 is going to stay on the numerator because negative numbers are fine. We can have negative numbers. We cannot have negative exponents in order for something to be simplified. So the -7 stays where it is. B to the 3rd stays where it is. A to the -4th gets moved to a denominator. So we get -7 b to the 3rd power over a to the 4th power for our answer on number 3. So the only thing that changes, the only thing that I guess moves is something with a negative exponent. Negative numbers are fine. Positive numbers are fine. Positive exponents are fine. Negative exponents are the ones that have to be moved. All right. So that's the basics of the negative exponent rule. So before we move on to the rest of our lesson here, which is just a bunch of examples, we're going to read some directions here. It says to simplify each expression, which means we can't have negative exponents in our answer. But it says to make sure that the final answers contain only positive exponents. And the hint it is telling you here is use the rules first. Use the exponent rules first. Like use combining like terms. Use the product rule, the power rule, the quotient rule. Use all of those things first. Then at the end, if you have any negative exponents in your final answer, then move things from top to bottom or from bottom to top. So like on this one here, number 4, we're not going to move the W to the -9 to the bottom right away. What we're going to do is we're just going to go ahead and use the product rule. He's not here. We're going to use the product rule first by adding together the exponents. Because we have 2 of the same variable, which means we're allowed to add the exponents using the product rule. So we got 7 plus -9. That gives us W to the -2nd power by adding together the exponents. Now we still have a negative exponent, which means we do have to use the negative exponent rule by making this W to the -2, put that on a denominator. And the only thing that's left on the numerator would be a 1 because we're moving the whole thing to the denominator. So we end up with 1 over W squared. So that's our answer for problem number 4. And if you have any questions, please let me know. The negative exponent rule is oftentimes the one that can be kind of the trickiest one. So if you got questions on any of this, please ask if you need some help with it. All right, number 5. Again, this is very similar to what we saw on yesterday's quiz, really. We're going to use the product rule here. So we have to multiply the regular numbers. 4 times 5, that's 20. And then we're going to add the exponents that have the same variables. So 8 and -5. If we add 8 plus -5, that's just going to be +3. So that's C to the 3rd power. And then d to the -3rd times d to the -1, add those together. -3 plus -1 is -4. So that would be d to the -4 power. So just using the product rule, we get 20 c to the 3rd d to the -4. We still have one variable here with a negative exponent. So d to the -4 needs to be put as a denominator underneath the 20 and the c to the 3rd power. So the answer to this one would be 20 c to the 3rd over d to the 4th power. So that's our answer for number 5. All right, 6 and 7 are both product rules again, starting off with, and then use the negative exponent rule after that. I would like you to try to do number 6 and 7 on your own, and then we'll check back in a couple minutes. go with another 30 seconds or so. If you have any questions, let me know. I'm going to be calling on a couple random people as well to help out with 6 and 7. Okay, let's see. So number 6, Karime, do you have anything for number 6? No? Okay. Let's go ahead and just do the multiplication then first. So we got 6x to the negative 8 times negative 3x to the negative third. We're just going to start by multiplying the 6 and the negative 3. So what does that give us? 6 times negative 3. Or 6 times 3, make it negative. If you need a calculator, feel free to grab one. But what number do we get in front of this one? Somebody go ahead and tell me. 6 times negative 3. Yeah, real quick. Yep. 6 times negative 3. Anybody? Regular multiplication. I know we know this. Negative 18. There we go. So negative 18. All right. And then x to the negative 8 times x to the negative 3. We need to add together those two exponents. So what does negative 8 plus negative 3 equal? Negative 8 plus negative 3. I see a lot of calculators out there. Negative 11, yeah. So x to the negative 11. So we're looking at negative 18, x to the negative 11. And so in order for this to be fully simplified, we're allowed to have this negative 18 here. What we can't have is the exponent of negative 11. So this has to move underneath the negative 18. So our answer for number 6 is going to be negative 18 over x to the 11th power. So making that negative exponent positive means moving it from the numerator to the denominator. All right, are there any questions on that one before we look at number 7? All right, so let's see. I would like, oh, not here, not here either. Let's see, Gabriella, do you have anything for number 7? Let's just go the first step. So adding our exponents, what do we get? A to the, yeah, B to the 5th, yeah. C to the negative 5th, yeah. All right. So adding our exponents together, a to the negative 5th, a to the 7th, negative 5 plus 7 is 2. B to the 8th, b to the negative 3rd, 8 plus negative 3 is 5. C to the negative 12th, c to the 7th, negative 12 plus 7 is negative 5. So our first step is just using the product rule by adding together the exponents that have the same variables. And then what do you have for your final answer? Yes. A to the 2nd, b to the 5th over c to the 5th power, because we need to move only the variable that has the negative exponents as a denominator, keeping the a squared and b to the 5th on the numerator. Good. All right. So this is how we're using the product rule and then the negative exponent rule. So we're really just kind of adding one thing. We're using the regular rules that we did. We're just introducing some negative exponents. And if we still have negative exponents, after we use the rules, we have to move some things around from numerators to denominators, or maybe the other way around that we might see later. All right, number 8, 8 through 11. These are going to be power rule examples. And so what we're going to do on number 8 is we're going to use the power rule first. And I'm actually going to do something a little bit different with this one, because if the entire thing in parentheses is taken to a negative exponent, there's a couple things, there's actually 2 ways that you can work through this, and I'll show you both ways. The first thing you could do is you could just apply the -2 to the 8 and the -2 to the 5 using the power rule, which would look like, I'll just try to set this up and show you both ways here. So that would be 8 to the -2 times p to the -10. Because you're applying using the power rule, so that would be 8 applied to the -2 power there, and then 5 to the -2 power, multiply the exponents. 5 times -2 is -10. Now, the thing that ends up happening on this is that because these are both negative exponents, you end up with a 1 over 8 squared p to the 10. And 8 squared is 64 because it's 8 times 8. So the answer would be 1 over 64 p to the 10th power. So that's one way to look at this problem. The other way we could do this one is, because the entire multiplication is inside parentheses and we have a negative exponent on the outside, we could just turn everything in here into a denominator to start things off. So we could start off by saying 1 over and then 8p to the 5th to the 2nd power, like that. And because we're taking this whole thing and making it a denominator, that means that the exponent is now positive instead of negative. So this is the other way to do this problem. And then you would apply the exponent of 2 to both of those. And 8 to the 2nd power, 8 times 8 is 64. And then 5 times 2 gives us p to the 10th power. So it's the same answer either way. But it's just one, it just depends on which one of those 2 methods kind of makes more sense to you. If they're both challenging, I get that. But if one makes a little more sense than the other, then I'd say go with that method. So I prefer, when I'm doing these, to use this method over here. Because if everything there is having a negative exponent applied to it, you can just change everything right away to make it all positive and then deal with the rest of it after that. So you don't have to. I know it says to use the rules and then move the variables at the end. In a lot of cases, that's the easier thing to do, especially with the product rule. But sometimes, not all the time, but sometimes with the power rule, if you've got everything in your parentheses and that one set of parentheses is taken to a negative exponent, you can make that negative exponent positive right away and then go with the rest of it after that. So for number 9, I would actually say, let's just go ahead and write 1 over 5y to the 2nd power, and then that's all to the 3rd power because our negative exponent is now positive because we moved it to the bottom. And then we take 5 to the 3rd power, which is 5 times 5 times 5, that's 125. And then y to the 2nd to the 3rd, multiply your exponents would be y to the 6th power. So we end up with 125, or 1 over 125 y to the 6th power for problem number 9. So it kind of depends on the method that you would prefer. We can do the other method on this one. So we can apply the negative exponent all the way through first, which would be 3 to the -4, r to the -4, and then -3 times -4 is +12, so the s to the 12th power. And so we've got 2 things here with negative exponents, 1 without. So the s to the 12th is going to stay up on the numerator. The other 2 are going to move to the denominator. So that would be s to the 12th over 3 to the 4th power, and then r to the 4th power. And 3 to the 4th power, will expand that out. 3 times 3 times 3 times 3, which is 81. So that's s to the 12th over 81 r to the 4th. And that's the answer that we would get for problem number 10. So depending on which method you would prefer to use, just the power rule straight away, or flip it over first and then the power rule, that's up to you. Number 11, I'm going to flip it all first. And so that would give us 1 over 6x to the 5th, y to the negative 4th, all to the 2nd power, because that exponent is now positive. And notice that when we flip this, the stuff inside the parentheses doesn't change at all. It's only the exponent on the outside that goes from a negative to a positive. Everything in here stays the same. X to the 5th stays x to the 5th. Y to the negative 4 stays y to the negative 4. And so we can apply that exponent of 2 to everything on the denominator. So that would be 1 over 6 squared is 36. 5 times 2 is x to the 10th. And y to the 4th to the negative 2. Negative 4 times 2 is negative 8. So that's y to the negative 8. Now, here's the first time that we have seen a negative exponent on a denominator. Does anybody have any ideas on what we could do to make this y to the negative 8 a positive exponent? Because we can't have negative exponents in our answer or in our simplified form. Kelly, what do you think? Move it to the top, exactly. If you have a negative exponent on the top, to make it positive, you move it to the bottom. So if you have a negative exponent on the bottom, to make it positive, you just move it to the top. So it's exactly the opposite. Wherever it's negative, move it to the opposite side of the fraction, and that'll make your exponent positive. So that'll give us y to the 8th power over 36x to the 10th. That'll be our answer for number 11. Okay, any questions there? These will continue to get a little bit more challenging, especially when we get to page 2. But right now we're just going through product rule, power rule, and then the last 4 on this page are going to be the quotient rule. So let's go ahead and have a look at the quotient rule, how it applies here. Whenever you have the quotient rule, you're going to subtract the exponents. So 2 minus 5 would be negative 3. So that would be h to the negative 3, which would then equal 1 over h to the 3rd power. And so that's our answer for number 12. Subtract the exponents. If you have an exponent that's still negative, move it to the opposite side of the fraction to make it positive. 13, same idea. C to the negative 2, d to the negative 1 over c to the 7th, d to the negative 2. And again, we're going to get into some subtracting of negatives on this one. So again, if you need to use your calculator to help you out with the minusing negatives and things like that, feel free to do that. Negative 2 minus 7 is negative 9. So that's c to the negative 9. And then negative 1 minus negative 2 is the same as negative 1 plus 2, which is just 1. So that would be d. D to the 1st power, or just d. So c to the negative 9 times d, which would equal, move the c to the negative 9 underneath. So that'd be d over c to the 9th power. And that's our answer for number 13. So pretty much using the exponent rule first and then using the negative exponent rule at the end. Unless, of course, you'd like to use the method that I showed you for the power rule, you're welcome to do that. Either way works for those ones. All right, try 14 and 15 on your own. Take a couple minutes on those. Use the quotient rule first, then the negative exponent rule if you need to. And you might not always have to use the negative exponent rule. Just because there's negative exponents to begin with doesn't mean that there will be in the end. So here's the answer for number 14. We got 2w to the 6th power. That's it. 14 divided by 7 is 2. 4 minus negative 2 is actually 4 plus 2, which equals 6. So we get 2w to the 6th power for problem number 14. So there's no negative exponents to move around once we use the quotient rule on number 14. Number 15, does anybody have an answer they'd like to share on that one? Or at least the first step? Anybody have something after the first step that they'd like to share on this one here? How about the number? What's the coefficient going to be? Negative 10 divided by 2 is what? Negative 5. And then subtract our exponents. 2 minus 3, what does that equal? Negative 1, so m to the negative 1. And then 1 minus negative 5. Positive 6, good. So after our first step here, using the quotient rule, we get negative 5, m to the negative 1, n to the 6th power. So the only thing here that has a negative exponent still is m to the negative 1. So we need to move just the m to the negative 1 to the denominator. So we'll end up with negative 5, n to the 6th power over m. Or m to the 1st power on the bottom, however you want to write that. So negative 5, n to the 6th over m for number 15. All right. Are there any questions from this first page that we need to get more in depth with? If not, we'll keep going. All right, page 2. Let's see. We'll do a couple of these ones up top. We won't do all 4 of the 16 through 19. We'll just pick a couple of these and clear that image up a little bit. Yep. Let's look at 17, and we will also look at 19. So we'll look at 17 and 19. So 17 says 15 over 18, which will reduce as a fraction, but we're not going to get a whole number because the numerator is smaller than the denominator. Those are each divisible by 3. 15 divided by 3 would be 5. 18 divided by 3 would be 6. So we're going to have 5. And then a to the 2nd divided by a to the 2nd, those will actually just cancel out altogether. And then b to the 5th divided by b to the 3rd power, 5 minus 3 is 2, so that would be b squared. And then c to the 8th divided by c to the 9th, 8 minus 9 is negative 1, so it'll be c to the negative 1 all over 6. So 5b squared c to the negative 1 over 6. And we still have one thing we need to do because there is a negative exponent still. And so we need to get rid of that negative exponent, or I guess move the negative exponent to make it positive. So the c to the negative 1 is going to move to the denominator down here at the 6. So we're going to end up with 5b squared over 6c. And that's the answer for number 17. 5b squared over 6c. So we use the quotient rule first, then the negative exponent rule to make sure that all of our exponents were positive at the end. Any questions on that one? All right, let's look at 19 then. Negative 9 r squared s to the 6th t to the 4th over 54 r to the 5th s squared t to the 8th. So kind of a lot happening here, but still it's just quotient rule first and then moving things around if we need to after that. Negative 9 and 54, what does that reduce to? Negative 9 over 54. You can just plug that right into the fraction part of your calculator if you need to. Negative 1/6. Yep. So negative 1/6 is what that reduces to. So negative 1, and then r squared divided by r to the 5th. 2 minus 5 is negative 3, so that's r to the negative 3. 6 minus 2 on the s's would be s to the fourth. And then 4 minus 8 for t would be t to the negative 4, all over 6 again. So negative 1, r to the negative third, s to the fourth, t to the negative fourth over 6. Okay. There are two variables here that have negative exponents. So the r and the t both need to be moved to the denominator in order for this to be fully simplified. So we're going to end up with negative 1 s to the fourth over 6 r to the third t to the fourth power. And that is the simplified form for number 19. Again, we're okay having a negative number. We just can't have negative exponents in our final answers. Okay, on to some mixed practice now, because everything we've done so far has just been one individual skill at a time. Now we're going to do some mixing and matching. And we might even try the very last one as well, that challenge problem. So let's see, we'll pick a few of these to do. Let's go with, trying to think of some ones that we can do and which ones we can skip. Well, we'll definitely do number 20 because that's the only one that has addition. So we'll start with that one. So problem number 20. We're going to use the power rule first and then the combining like terms perhaps after that. So we're going to apply our -2 exponent to everything in the first set of parentheses, then -3 exponent to everything in the second set. And you can do this one of two ways. You can flip everything first to make these exponents positive, or you can just apply the exponents first and then flip things around as you need to. So I'm just going to do that. I'll say 4 to the -2, and then x to the -6, and y to the -12, plus, that would be 2 to the -3 power, x to the -6 power, and then y to the -12th power. All right. So I would actually suggest keeping it like this because we can see that we've got like terms, right? -6 with x, -12 with y. So these are like terms. So let's go ahead and multiply out these. Well, let's see. Let's go ahead and flip everything, actually. How about that? So that'll be 1 over, because everything is a negative exponent, 1 over 4 times 4, 4 squared is 16, x to the 6th, y to the 12th. And then plus 2 to the -3, so we're going to put 1 over 2 to the 3rd power, which is 8, x to the 6th, y to the 12th. So really what we're looking at is, in terms of adding together, we're adding 1/8 and 1/16 together. Those are the two numbers that we're actually adding for our like terms here. So we can just do that in our calculator if we want to. So 1/16 and then over plus 1/8. That's going to be 3/16 when we get there. So we're only adding the coefficients, just like we normally would. And just because it's a fraction doesn't mean the rules change. The rules are exactly the same. So 1/16 plus 1/8 equals 3/16. So our final answer then is going to be 3 over 16 x to the 6th, y to the 12th. So it ends up being a fraction. We've seen a lot of answers like this before. We just haven't had to deal with the negative exponents yet. So we'll just move those things around like we need to, and we'll keep our exponents positive at the end. Using all the other same rules that we've already learned. All those other rules still apply here in terms of combining like terms, power rule, product rule, quotient rule. We're just making some adjustments to make sure that all of our exponents are positive. Are there questions about number 20? All right. Let's go with 23 next. We'll skip 21 and 22. We'll try 23 next, because 23 will use the same stuff as 21 and 22, but all together in one problem. So 23. We're going to use the power rule first on the numerator. So this one actually looks really similar to some of the ones that we've looked at the last couple of days. So power rule first. 3 to the second power, 3 times 3 is 9. X to the second power times y to the second power. And then this next set of parentheses, because there's no exponent on the outside of it, we don't really need those parentheses. So we can say times 2x to the fourth, y to the third. And that all goes over 6x to the eighth y. So step 1, use the power rule. Step 2 is to use the product rule on the numerator. So use the product rule on the numerator, which we've done many, many times. So 9 times 2 is 18. X squared times x to the fourth, add the exponents. 2 plus 4 is x to the sixth power. Y squared times y to the third, 2 plus 3 is y to the fifth power. Over 6x to the eighth y. So power rule first, product rule second. Now we're going to use the quotient rule. We have to divide and subtract the exponents now. So 18 divided by 6 is 3. And then x to the 6th divided by x to the 8th. Subtract the exponents. 6 minus 8 is negative 2. So that's x to the negative 2 power. And then 5 minus 1 is 4. So that'd be y to the fourth. So 3x to the negative 2, y to the fourth. And the last thing we need to do is just make sure that this x to the negative 2 isn't negative anymore. So we'll just move the x to the negative 2 to the denominator. And so we'll have 3y to the fourth on the numerator over x squared. And that will be our answer for number 23. All right, questions on that one? So really, I mean, we're only adding one thing today, and that one thing is if we end up with a negative exponent, we just kind of move it to the opposite side of the fraction. That's really what it boils down to. 25, we'll skip 24, we'll do 25 and then the challenge problem, and then we'll be done. So 25, here we go. We're going to have the product rule on the numerator and the denominator. We're not going to use the power rule at all because there are no exponents on the outside of parentheses here. And then we'll use the quotient rule after that and see if there's anything negative to deal with at the end. So 6 times 3 on the top, that's 18. B and then b to the fifth, add the exponents. 1 plus 5 is b to the sixth power. And then c to the third, c to the second, 3 plus 2 is c to the fifth. Over. Product rule in the denominator as well. 5 times 2 is 10. B to the fifth, b to the third, add the exponents, that's b to the eighth power. And then c to the second, c to the sixth, add the exponents, that would be c to the eighth power. This is what we're at right now. Now we can use the quotient rule. 18 divided by 10 is not a whole number, so we're just going to have to simplify this. And 18 and 10 are both divisible by just 2. So that would be 9/5. So we're going to have 9. And then 6 minus 8, subtract the exponents, that's negative 2. So b to the negative 2. 5 minus 8 is negative 3. So c to the negative 3. And that's all over 5 because we reduced that fraction from 18/10 to 9/5. And so the last thing that has to happen here is take our two variables and move them both to the denominator to get those exponents positive. So we're just going to be left with 9 on the numerator over 5 is still down here, and then b squared c to the third. So 9 over 5b squared c to the third is what we end up with on number 25. We're going to do one more, and then you'll have the remainder of class to work. So you have about 20 minutes of work time today, which is great. So questions on 25? Okay, last one then. Here we go. 20, not 26. It's just the challenge problem. So here we go. There's a lot going on here. What I would recommend is completely simplify everything inside the overall parentheses first, then apply the exponent of 3 at the end. So let's go ahead and work on everything inside here first, and then we'll deal with this exponent out here at the end. So Everything inside numerator is going to be the power rule twice. So we'll start there. So 2 to the negative 2 power, so that's 2 to the negative 2 power. And then 4 times negative 2 would be x to the negative 8. And then negative 3 times negative 2 would be y to the 6th. And then times 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. So times 16. Actually, you know what? I'm going to say 2 to the 4th power, and I'll tell you why in a second. I'm going to go 2 to the 4th power. And then x to the negative 4, because we're multiplying the exponents. And negative 2 times 4 is negative 8, y to the negative 8th power. And that's all over the original denominator of 2x to the negative 7, y to the negative 3rd power, and that all is taken to the 3rd power. All right, now chances are, I shouldn't say chances are, you will not see a question like this on the test. I'll just be upfront with that. You won't see a question like this on the test. This is more or less just a way to use all the rules that we've learned and kind of see what's going on. So on the numerator, the reason why I didn't multiply out 2 to the 4th power when I was initially going to do that is because I noticed it's the same number over here as 2 to the negative 2. So because these numbers are the same, we can do the same thing with these numbers and exponents as we're going to do with the variables and the exponents. If it's the same base value, you're allowed to add together the exponents. So instead of multiplying out 2 to the negative 2 and 2 to the 4th, let's just add the exponents with those. Negative 2 plus 4 is positive 2. So that would actually give us, on the numerator, 2 squared, which makes life a little bit easier. And then we can add the exponents on the other one. Negative 8 plus negative 4 is negative 12, so that's x to the negative 12. And then 6 plus, oops, and then 6 plus, thank you, 6 plus negative 8 is negative 2, so y to the negative 2. So 2 squared, because those 2's are the same value, which means we are allowed to add the exponents as long as you have the same base value. And then on the denominator, it's still the same. 2x to the negative 7 and y to the negative 3, and that's all to the 3rd power. So things are condensing pretty quickly here. And on the next step, 2 times 2 is 4, right? We all know that. So I'm just going to say, all right, that's 4. That way we don't have to worry too much about writing out too many steps. And so now we can just use the quotient rule. So the quotient rule says 4 divided by 2, that's 2. Negative 12 minus negative 7 is the same as negative 12 plus 7, which is negative 5. So that would be x to the negative 5th power. And then negative 2 minus negative 3 would be negative 2 plus 3, which is just 1. So that would be y. And then that's all to the 3rd power. All right, so the last thing, or actually there's 2 more things we should do. At this point, we don't need to move this x to the bottom yet as a denominator. We can apply the 3 now, since everything is nice and simplified on the inside. So that would be 2 to the 3rd power. 2 times 2 times 2 is 8. And then multiply the exponents. X to the negative 5th times 3 is negative 15. So x to the negative 15th. And then y to the 3rd power. Now we can go ahead and move this x to the negative 15 to the denominator. And we're done after that. So we keep the 8 and the y to the 3rd power on the numerator. And that's all over x to the 15th now, it's positive 15. As you move it to the bottom, and that is the simplified version of this original one, which looked really crazy. So that condensed quite a ways. And the reason why it condenses so much is that if you look at the original problem, there's only 2 variables to begin with, x and y. So your final answer, you're just going to have one of each of those, plus whatever number is left over. So one number, an x and a y, with some exponents, and that's what we end up with. All right. So that is it for today's notes.